Hello, I'm Robert Miles. Welcome to this recording of the Alignment Newsletter podcast. This is newsletter number 55, published on the 5th of May 2019 by Rohin Shah. The improvements to the newsletter continue. This is getting very meta. Rob Miles has generously volunteered to make the Alignment Newsletter podcast. Chances are that the podcast will trail a week behind the emails, unless I manage to get my act together and give Rob a preview of the newsletter in advance. Hopefully it'll be less than a week, but yeah, they'll definitely trail a bit. Highlights. Link, Standards for AI Governance. International standards to enable global coordination in AI research and development. This technical report argues that we can have an outsized impact on the future of AI by influencing standards on AI so that they help ensure that AI systems are safe and beneficial, in addition to making the deployment of AI more efficient. A standard here could be a product like TensorFlow or GYM, or a process like this list. That's a link to Google's responsible AI practices. It's particularly useful to focus on international standards. Since corporations can simply leave the country to escape national regulations, there's a race to the bottom on the stringency of national standards, and so they can't affect as much change. It may be particularly valuable to influence existing organizations that set standards, because they're very responsive to expert opinion. It's also possible to develop a standard privately and then convert it into an international standard. This happened with the C programming language and the PDF file format. Such influence can be used to change the culture around AI development, for example, to put safety more at the forefront. Rohin's opinion. I would guess that the most influential standards are network standards, like TensorFlow. They make it easier for everyone to develop AI systems. However, the benefit here is in having any standard at all, and so it seems unlikely that such standards could also affect a change in culture that's unrelated to the efficiency aspect of the standard. That said, the report convinced me that enforced standards are also impactful. Even if the standard requires active enforcement to prevent organizations from ignoring it, organizations will often choose to comply with the standard in order to get a certification that builds consumer trust in them. Link, Regulatory Markets for AI Safety, by Jack Clark et al. This paper presents an idea on how AI could be regulated, by the introduction of a market of private regulators that themselves are regulated by the government. Companies would be required by law to purchase regulatory services, but could choose which regulator they purchase from. The regulators compete to attract companies, but all are required to meet goals set by the government. The key benefit of such an approach is that the government now only needs to set goals for regulation, for example, for self-driving cars, a limit on the rate of accidents, while offloading to private regulators the regulations on processes, for example, required adversarial training on the vision models employed in self-driving cars. This relieves the burden on government, which is currently too slow-moving to effectively regulate AI. It gets the best of both worlds. As with government regulation, it can optimize for the public good, and as with tech self-regulation, it can have best practices emerge from the researchers who know best, since they can build their own regulatory startups. Of course, for this to work, it's crucial that the private regulators avoid regulatory capture, and that the market for regulators is competitive and independent. Rohin's opinion. This seems very related to the notion of an enforced standard in the previous paper, though here it's only necessary to enforce the goal across everyone, and the details of processes can vary across regulators. I especially like the scenario in which regulators emerge bottom-up from researchers thinking about potential problems with AI, though I'm not sure how likely it is. With both this and the previous paper, I can see how they would apply to, for example, self-driving cars and adversarial robustness, but it's less clear to me how much an approach can help with AI alignment. If we believe that alignment is really hard and we only get one shot at it, then it seems especially difficult to have legible regulations that ensure, without any testing, that we don't build a misaligned superintelligent AI. Alternatively, if we believe that we will have lots of non-catastrophic experience with aligning AI systems and can iterate on our processes, then it seems more likely that we would develop useful, legible regulations. I'm more inclined to believe this latter scenario, based on comprehensive AI services, discussed in newsletter number 40, and other intuitions. Even in this scenario, I don't yet know what regulations I would place, but it seems likely that with more experience we would be able to develop such regulations. Section Technical AI Alignment. Subsection Technical Agendas and Prioritization. Link Overview of AGI Safety Research Agendas by Rohin Shah. The video from my talk at the Beneficial AGI conference has just been released. In this talk, I cover 5 broad safety-related areas that people are investigating. Almost everything here is a link, so I won't call them all out. Understanding the future of AI, for example, embedded agency, discussed in newsletter number 31, and comprehensive AI services, discussed in newsletter 40. Limiting the influence of an AI system, for example, boxing, discussed in newsletter 54, and impact regularization methods, discussed in newsletter 49. Robustness, for example, verification, discussed in newsletter 19, and red teaming. Helpful AI systems, for example, ambitious value learning, discussed in newsletter 31, preference learning, cooperative IRL, corrigibility, discussed in newsletter 35, factored cognition, in newsletter 36, iterated amplification, and debate in newsletter 5, and interpretability, discussed in newsletter 49. My podcast, discussed in newsletter 54, covers almost all of this and more, so you may want to listen to that instead. Link FLI's YouTube channel. Section Preventing Bad Behavior. There's 2 links. Self-confirming predictions can be arbitrarily bad, and Oracle's Sequence Predictors and Self-Confirming Predictions, both by Stuart Armstrong. Let's consider an Oracle AI system tasked with accurate prediction, with a strong enough world model that it could understand how its prediction will affect the world. In that case, accurate prediction means giving a prediction P such that the world ends up satisfying P, given the knowledge that prediction P was made. There need not be a single correct prediction. There could be no correct prediction. Imagine predicting what I will say, given that I commit to saying something different from what you predict. Or there could be many correct predictions. Imagine instead that I commit to say whatever you predict. These self-confirming predictions could be arbitrarily bad. Part of the point of oracles was to have AI systems that don't try to affect the world, but now the AI system will learn to manipulate us via predictions such that the predictions come true. Imagine, for example, the self-confirming prediction where the oracle predicts 0 profit for a company, which causes the company to shut down. In order to fix this, we could have counterfactual oracles, which predict what would have happened in a counterfactual where the prediction couldn't affect the world. In particular, we ask the oracle to predict the future given that the prediction will immediately be erased and never be read by anyone. We can also use this to tell how much the prediction can affect us by looking at the difference between the unconditional prediction and the prediction conditioned on erasure. Read more, link Good and Safe Uses of AI Oracles. Section AI Strategy and Policy. Link Google's brand new AI Ethics Board is already falling apart, by Kelsey Piper. Google announced an ethical advisory council that quickly became controversial and was then cancelled. The author makes the point that the council was not well placed to actually advise on ethics. It would only meet 4 times a year and could only give recommendations. This committee, and others at Facebook and Microsoft, seem to be more about PR and less about AI ethics. Instead, an AI ethics council should include both insiders and outsiders, should be able to make formal, specific, detailed recommendations, and would publicly announce whether the recommendations were followed. Key quote, "The brouhaha has convinced me that Google needs an AI ethics board quite badly, but not the kind it seems to want to try to build," end quote. In a tweet storm, that's a link, the author holds OpenAI up as a large organization that is at least trying to engage deeply with AI ethics, as evidenced by their safety and policy team, their charter, discussed in newsletter number 2, and GPT-2, discussed in newsletter 46. They make public, contentful statements that are weird, controversial, and seem bad from a PR perspective. The arguments they make and hear about AI ethics and policy lead to real decisions with consequences. Rohin's opinion. I broadly agree with this article. I can't imagine how a council that meets 4 times a year could properly provide advice on Google's AI projects. I'm not sure if the solution is more powerful and intensive ethics councils whose primary power is public accountability. I expect that making good decisions about AI ethics requires either a technical background or a long, detailed conversation with a person with that background, neither of which are possible with the public. This could mean that an ethics board could struggle to raise a legitimate issue, or that they could cause outrage about an issue that is, upon closer examination, not an issue at all. I would feel better about a board with some more formal power, such as the ability to create investigations that could lead to fines, the ability to sue Google, specific whistleblowing affordances, etc. I have no idea how feasible any of those suggestions are, even assuming Google was okay with them. On the tweet storm about OpenAI, I'm not sure if I've said it before in this newsletter, but I generally trust OpenAI to be doing the right thing, and this is one of the reasons for that. Of course, I also know and trust many people who work there. Link, Rationally Speaking, number 231. Helen Toner on Misconceptions about China and Artificial Intelligence, with Julia Galef and Helen Toner. In this podcast, Helen talks about AI policy, China, and the Center for Security and Emerging Technology, where she is the Director of Strategy. Some of her opinions that stood out to me. While Baidu is a large tech company and is the main search engine, it's a bit misleading to call it the Google of China, since it doesn't have the same diversity of products that Google does. While the social credit score story seems overblown, the reporting on the Uyghur situation seems to be basically accurate. Based on a very small sample of AI researchers in China, it seems like Chinese researchers are less interested in thinking about the real-world effects of the technology they're building relative to Western researchers. Since people in government have so little time to think about so many issues, they have simple versions of important ideas. For example, it's easy to conclude that China must have an intrinsic advantage at data, since they have more people and fewer privacy controls. However, there's a lot of nuance. For example, most of the internet is in English, which seems like a big advantage for the US. The incentives in China can be quite different. In at least one case, a chemistry professor's salary depended on the number of papers published. A particularly interesting question: how does it help the US geopolitically if an American company is developing powerful AI? Link, When is it appropriate to publish high-stakes AI research? Following the GPT-2 controversy, discussed in Newsletter 46, the Partnership on AI held a dinner with OpenAI and other members of the AI community to discuss the tension between the norms of openness and the desire to mitigate potential unintended consequences and misuse risks of AI research. The post discusses some of the relevant considerations and highlights a key conclusion. While there is not yet a consensus on review norms for AI research, there is a consensus that whatever the review norms are, they should be standardized across the AI community. Rohin's opinion. I definitely agree that having everyone follow the same review norms is important. It doesn't do much good to hold back from publishing something problematic if a different group will publish all of the details a few weeks later. However, getting everyone to agree on a change to the existing norms seems incredibly hard to do, though it might be feasible if it was limited to only the largest actors who can engage deeply in the debate of what these norms should be. Section Other Progress in AI. Subsection Unsupervised Learning. Link, Unsupervised Learning, The Curious Pupil, by Alexander Graves et al., summarized by Cody. A high-level but well-written explanation of why many believe unsupervised learning will be key to achieving general intelligence, touching on the approaches of GANs and autoregressive models as examples. Cody's opinion. This is a clean, clear summary, but one without any real technical depth or detail. This would be a good write-up to hand someone without any machine learning background who wanted to get an intuitive grasp for unsupervised learning as a field. Link, Evaluating the Unsupervised Learning of Disentangled Representations. This blog post and paper describe a Google-scale comparative study of different representation learning methods designed to learn disentangled representations, where the axes of the representation are aligned with the true underlying factors generating the data. The paper's claims are a sobering result for the field, both theoretically and empirically. Theoretically, they show that in an unsupervised context, it's not possible to find a disentangled representation without embedding some form of inductive bias into your model. Empirically, they present evidence suggesting that variation between random seeds for a given hyperparameter setting, in particular regularization strength, matters as much or more than variation between that hyperparameter's values. Finally, they run experiments that call into question whether disentangled representations actually support transfer learning, or can be identified as in fact being disentangled without using a metric that relies on having ground truth factors of variation to begin with, making it difficult to evaluate on the many realistic contexts where these aren't available. Cody's opinion. This strikes me as a really valuable injection of empirical realism, of the kind that tends to be good for research fields to have periodically, even if it can be a bit painful or frustrating. I appreciate in particular the effort and clarity that this paper puts into articulating the implicit assumptions of how disentanglement can be used or evaluated, and trying to test those assumptions under more real-world settings, such as the one where you don't have any ground truth factors of variation, since the real world doesn't tend to just hand out the correct factorized model of itself. Link: Robots that learn to use improvised tools. This concludes Alignment Newsletter number 55. For more information, you can go to rohinshah.com/alignment-newsletter, where you can find all of the previous newsletters and also a spreadsheet of all of the papers and summaries that have ever been in the newsletter. Thank you for listening.